Can you believe that these were once the soda bottles that we drank and threw away? This is a plastic recycling plant in India where they turn waste into giant water pipes like this. But to do that, they have to go through a very special process that I will explore with you today. If your family throws away 10 plastic bottles a week, do you think they could be turned into something useful? Comment and let me know. First, I was invited to the quality control area, where they test the pipes by pumping them with extremely high water pressure. If the pipe doesn't burst, it's ready for installation. I really like how the factory uses a real-world testing method, which ensures durability and prevents defective products from entering the market, something that many small recycling plants often ignore. What other factors do you think the factory should test to ensure long-term safety of the pipes? In the first workshop, old plastic bottles are dumped into the yard and sorted by hand. Workers separate water bottles, large plastic cans, and even boxes. What impressed me was the meticulousness. Each cap and paper label is removed with a sharp knife or bare hands. In conditions lacking machinery, using manual labor helps create jobs for local people, but also poses many health risks from plastic dust and chemicals left in the bottles. Do you think this model could improve the working environment if supported by cheap mini label and cap peeling devices? Comment your ideas. After being cut and labeled, the plastic pieces are poured into a large water tank to wash away impurities and dirt. There are no industrial cleaning chemicals, just plain water and human power. Each batch is scooped up and dried in the sun. Although primitive, this method minimizes chemical emissions into the environment. However, the direct discharge of dirty water into the ditch is also a major problem that has not been solved. If it were you, how would you design a manual rough filtration system to reuse this water? The workers scoop the plastic scraps into buckets after cutting and pour them directly into the machine's mouth. Without filtering or further sorting, everything is heated directly in the machine's heating chamber. Anyone who has ever seen a modern extrusion line with a closed cooking chamber, a temperature sensor, and a pre-programmed pressing speed will be amazed by the machine here. A small electric or diesel engine is enough to operate the entire line. Inside the heating chamber, the temperature gradually increases, melting the plastic scraps into a thick liquid. The hot plastic block is pushed through the circular die head where the soft plastic tube is shaped. Just like that, long sections of milky white or opaque white tube flow out. Sometimes the workers even have to use their hands to gently pull to adjust the direction of the tube, avoiding twisting or sticking together while it is still hot. What surprised me was the efficiency of this system. Although simple, in just a few minutes, they can extrude a tube several dozen meters long, serving well for water supply and drainage systems in rural areas. This machine is a poor man's version of an industrial extruder, but that doesn't mean it's any less effective. It allows people to collect plastic scrap and recycle it on the spot without having to send it to large factories. If we can improve the extrusion speed control system or the water cooling system around the pipe, the product will be much more uniform. The number of distorted, bulging, or air hole sections of the pipe will be significantly reduced. In fact, the cost of manufacturing this cooling system is very cheap. Just a few meters of water pipe, a mini pump, and a tank are enough. What do you think about installing this device? Is it worth the investment? Try commenting your opinion in the section below. The hot plastic pipe that has just been extruded is still soft and easily deformed. To keep the shape and hardness of the pipe, the worker must quickly put the pipe into a water tank to cool it. In some places, they pour water directly onto the pipe. The cold water hardens the plastic in seconds. Although there is no circulating tank system or modern cooling equipment, this method still helps the product meet the standards for civil use, from watering plants, draining rainwater, to making garden stakes and fences. The next step is also extremely manual. The worker uses a large knife or a handsaw to cut each piece of pipe to a fixed length. There is no electronic measuring ruler or automatic cutting device. Only experience and the eye are enough to shape it. In your opinion, should this type of plastic pipe cutting process be retained because of its simplicity, or should it be improved with a length measuring tool and a sharp blade to reduce effort and increase accuracy? Comment and share your ideas. So, sometimes things that seem to be useless waste can become useful products, helping many people and contributing to environmental protection. If you also believe that all materials have a chance to be recycled, please leave a comment I support below this video. Don't forget to like, share, and subscribe to the channel to explore more simple but meaningful recycling processes like this.